physical graphs and exponential decay. Once again, we've got this recognizing exponential growth and decay equations and graphs. And so now, it's not just looking at the graphs. We're going to be giving you equations, and you've got to decide whether it represents growth and decay. And if you can understand that this growth is getting larger and decay means getting smaller, it should be pretty easy to recognize both of those. And then we're going to use those exponential decay models. Exponential decay is if it's decreasing by the same percent in each year. A couple of words that mean decrease, depreciate is another word for decay. And so you may not see that it's decaying at this rate, but often when we talk about cars, because the car itself is not actually decaying away. It's the value of it. And so when we talk about the value of something going down, we say it depreciates. So that's kind of our key word for decreasing. But it's that same percent in each year. So if we take a look at the formula, ladies and gentlemen, you should be able to fill in what each of those variables stands for, correct? Because they're the same variables we used yesterday. What does C stand for? This is our initial amount. And yesterday we learned that they'll call it the deposit, they'll call it the principal. And believe it or not, even if your parents can't help you with your algebra, they'll be able to help you with the vocab. They'll know that vocabulary, ladies and gentlemen, because it's not special to algebra, that's just like real life vocab. R is going to be what?
Rate.
The rate. And guess what that rate still has to be? It has to be your percent turned into a decimal. And then what is T going to be? The time. Often measured in years, okay? But when we start thinking about radioactive materials that decay, and you'll study some of that in your science classes, I feel like I studied that in chemistry. It decays, not necessarily over years, but over a different time period. So it's just whatever time period we're taking a look at. All right, so once again, we're talking about these exponential models, where we're putting in the C and the R, and then we're going to take a look at different time values. So write an exponential model for a $7,000 car. That's our C value. So if you need to go through on these word problems, guys, and label C and R. Walking around, it looks like most of us are getting the right numbers in the right spots. It's just manipulating that model. And it depreciates at a rate of 8% per year. So when we talk about that model, we're going to have y equals, we have our initial amount, $7,000, and we're going to multiply that by 1. But instead of adding, guys, what are we doing in this decay model? Subtracting. Okay? I'm taking away a little bit of that value every year. So I'm going to minus the 0.8%, or 0.08. And then I'm going to put in my T because I don't know how many years. It's going to help with today's lesson, ladies and gentlemen, if we actually look at what this is. What is 1 minus 0.08? Good job. Take 100 and minus 8, right, guys? 100 minus 8 is 92. What you're going to notice is on these growth models, or I'm sorry, on these decay models, this is always going to be less than 1. On the growth models, it's always greater than 1. So that's how we're going to distinguish between an exponential decay equation and an exponential growth equation. All right, but we'll take a look a little bit more at that later on in the notes. But it says now find the value of the car after 4 years. So our T value is 4. So now I'm going to go to my calculator. I'm going to type in y equals 7,000 times 0.92 to the 4th power. Guys, my board is getting off on its alignment, and it's a problem with the computer, so I need your help with your calculators. If you could do that, because I don't want to switch back and forth between my board and my calculator. So if I could have a couple of volunteers that will type these in at their seats, just so we can compare answers and make sure we agree. So what do we get when we take 7,000 and we multiply it by 0.92 to the 4th power? What's that car going to be worth, Izzy? For the first one, yeah? I got something a little bit different. Did anyone get 5,014 on theirs? Do you have the 0.92 here? Okay. Try the 0.92 because that's 1 minus. What that means, guys, if I'm losing 8% each year, does it make sense that I only have 92% of the car left?
Oh, sure.
All right. So what was that again, guys? I'm away from my calculator. $5,114.
Oh,
$5,014. And what's the cents, Andrew? What's the change going to be on that one? 75 cents. Good job. Yeah.
Do the 92, just do the 1 minus.
You can still keep the 1 minus 0.08 on your calculator. I'd like to show you guys the 92 so that you can actually see that that value you're multiplying by is less than 1, and that's what's making it decrease. It also helps us recognize a decay equation because this number is always going to be less than 1. All right. Write an exponential model for a population of 2,000 that decreases at a rate of 2.75% per year. So now we're talking about a population, which refers to people. All right, so we've got to think about how we're going to round these if we're talking about people. So my C value is still that 2,000. So we're going to have y equals.
This is a model.
Yeah. 2,000 times 1 minus. What am I going to do with this 2.75%? Divide it by 100 or move the decimal point 2 places. If you find, guys, that you're not putting your percents in as decimals, then you need to remember to do that division. So this is 0.0275. And then because it's a model, we have our t there. All right, but now we're finding the population after 9 years. So this is where we can quickly jump onto our calculator, and now we get to plug that 9 in for t. So we should see y equals 2,000 times 0.9725. If we look at that as terms of what we're multiplying by, that's the value that's less than 1, and raise that to the 9th power. Yes.
So can you still put the 1 minus?
Yep, that's exactly what Andrew asked. You can put it either way. Today I want to show you guys what that looks like, just so we get used to seeing that parenthesis, that factor being less than 1. And so we should come up with, ladies and gentlemen, 1,556 people. Because we're talking about a population, I can't have 1/100th of a person, can I? And so this is where, guys, they're not giving you any rules for rounding. You've got to think, is this money and I go to the nearest hundredths? Is this people and I keep it to the nearest whole number? All right, I believe we're done with the front side, correct?
Yeah.
All right, now we gotta go to the back side, and this is where we start putting together this idea of growth. We put it together this idea of decay and differentiating between the two and recognizing them. There's going to be a couple of vocab words they want you to look for. They're going to have you ask for what is the growth factor and what is the decay factor. The growth factor is whatever you're getting with the 1 plus r. The decay factor is that 1 minus r. So the growth and decay factor are whatever you're raising to the power, whatever you're multiplying that c value by. So for a growth, your parentheses are always going to be greater than 1. So if they're asking you to determine is it a growth or decay, it is growth whenever that parenthesis is greater than 1, because you were doing 1 plus some rate. Well, what do you think it means about the parentheses and a decay factor? They're less than 1. So if we understand what this idea of growth is, that I need to get larger, then I should be multiplying it by a number greater than 1. If I need to get smaller in decay, I should be multiplying by a number less than 1. So they're going to ask you for the factor. If they ask you for the factor, you're simply writing down what's inside those parentheses. But then what they're going to ask you for, guys, and this is where you have to start doing some math, either mental or on your calculator, they're going to want you to tell them what the percent of increase or decrease is. So that means you need to take R and multiply it by 100 to get it back to a percent. So we don't want just a decimal value, we want to actually see it as the percent. Okay? Do you guys have all of this on your notes, or is there some of it that you need to add in there? Do we have all those definitions on your notes? All right. So here's what the problems are going to look like. They're going to ask you to determine whether the given function is an exponential growth or decay function, give the growth or decay factor, and then give the percent of increase or decrease. All right? So if we take a look at that, is it growth or is it decay? I'm going to look at what's inside the parentheses. Is this greater than or less than 1? It's greater than 1. So if it's greater than 1, it's going to be growth. They then want to know the growth or decay factor. The growth and decay factor is simply what's inside those parentheses. So Eric, for this problem, what is inside those parentheses? 1.15. You're just going to write all of that down. Now remember that this 1.15 is 1 plus some R value. So when I look at that, can we see what our R value is? What did we add on to 1? 0.15. Does everyone agree with TJ that we added 0.15 on there? So my R value here is 0.15. But what they want is this percent of increase. So how do I take 0.15 and turn it back into a percent? Click. Move the decimal point 2 places. Or instead of dividing by 100, what am I going to do? Times by 100. What is 0.15 as a percent, ladies and gentlemen? 15%. That's all you're going to do. Growth ones are usually pretty easy because can we see the R value sitting right there in the problem? Yeah. So let's take a look at the next one. Lost my exponents here, guys. Sorry. I know, it's not very smart right now. So, is this growth or decay? Well, is this greater than 1 or less than 1? Less than 1. So what is that going to be labeled as? Decay. What's the decay factor? Sebastian, what's my decay factor going to be? 0.77. But remember, this decay factor was 1 minus some R value. I've got to figure out what that R value is. How would I figure that out? Heather?
Plus 1?
What do you mean by plus 1?
0.77 plus 1?
That's going to be 1.77, and I don't think my percent is going to be over 100%. So if I start losing more than 100% of something, then it's gone. Like, I have nothing left, and it wouldn't decay that quickly. TJ?
1 minus 0.77.
Good job. Ladies and gentlemen, you can just reverse this. If you take 1 minus 0.77, what does that give you? 0.23. That's going to give you your decay factor. You're going to kind of do the exact opposite. You're going to take what you have left. You're going to take that decay factor and subtract that to get your rate. So do we want to write this little step down? Some of you might want to. Sorry. So if I have 0.23, ladies and gentlemen, how do I turn that into a percent? Times it by 100. 23%. Alex, growth or decay? Jared, what's my growth factor? Cody, what's my R value if this is 1 plus R for a growth? I don't need the percent, just the R value. Good job. Just what's right after the decimal point, right, guys, for those growth ones? And then how am I going to turn this into a percent? Move the decimal point 2 places. 1.8%. Okay? Sebastian?
Wait, we doing 1 plus 1.018?
No, I'm doing 1 plus the rate, so it's 1, and then we had 0.018 that we added on to it.
Then you give
0.018, it's just what was after the decimal point, correct? And then I took that R value and turned it into a percent. Okay?